All right, so looking at A and B, I'm going to show you that I think substitution may be a bit of an easier route. Here's what gives that away for me. You know how when you do elimination, you're supposed to stack them up right on top of each other. These are kind of in a different order, like this is Y, X, and then number, whereas this is X, Y, and number. You could still stack them up, and it's not that big a deal, but you have to switch your orders. If you actually just add this 3Y over, you got X by himself over here. So I probably would just do that because that took like 2 seconds to do. And then I can just plug that 3Y in X's spot in the other equation. So that's what your new equation is going to look like. All right, and then you go through and you just solve it. Be really careful. I have some kids that distribute 4 to 3 and 4 to Y. You don't do that. There's no plus sign separating these. So 3Y is like one term. So if you do 4 times 3Y, it's 12Y. And then add them together and then divide. So you're going to get Y equals 2. Now that you know Y is 2, you can pick either equation you want, doesn't matter. I'm actually going to just use this one because that's pretty simple. And I can put 2 in Y spot, and X is going to end up being 6. And that one's done. Same thing here. Probably wouldn't do elimination for this just because I got my Y on the left, my X on the right, my number on the right, but in this one, X is on the left, and I would have to do a lot of some moving around, some shifting around, so it might not be convenient to do elimination. Instead, I know that Y is already isolated for me. When a letter is isolated, they're probably suggesting use substitution, it's easier. So we're going to plug 2x plus 4 in Y spot in the other equation. Remember, use parentheses when you're substituting, right? So parentheses around the whole group. And we're going to have to distribute, and you want to be careful. You have to treat this almost like it's saying minus. So if you do 3 times 2, you need a minus that 6. And if you do 3 times 4, you need a minus that 12. So you just make sure you have minuses in front of those. Right? We can combine 4 and minus 6 to make minus 2. We can add 12 to the other side to get 2, and then divide, and there's your answer for X. And again, you can pick either equation you want, doesn't matter. You now know what X is, so pick one, plug X in. I probably would pick that one because Y is already by himself. Probably going to be a little bit easier for me. Replace X with -1 and simplify, and boom, there's your answer. Now the other two, I'm definitely not using substitution. And here's why. If you're going to use substitution, you're going to divide everybody by 5, and that's going to make 2 fractions. Or if you get this letter by himself, you're going to divide everybody by 13. I don't want to work with 11 thirteenths and 5 thirteenths. So the smart way to do this is to stack them up. They're already in order. This is totally set up for elimination. Just stack them right on top of each other. Now, even the A's are already the same. I just need one of them to be negative. So change all the signs in either row. I picked the bottom, and then add it up. All right, 13 plus -13 is 0, so that gets crossed out. 5 plus -11 is -6. -11 plus -7 is -18. And then divide. And now you got your B. And ideally, you would now take this 3 and stick it in for B somewhere and then solve. Now I'm going to go a little fast through that because it gets a little redundant after a while. But there's the work that goes behind my thought process. So whichever one you do, it doesn't matter, you should get -2 for A. Now, letter D, you definitely can stack them up right as they are. There's nothing wrong with that. However, I do want to show you a little catch that can sometimes minimize your workload. Doesn't always, but most of the time it does. If you see your numbers have anything in common, like these are all even, you can divide everything by 2. Just like you can multiply everybody, you can also divide everybody. Multiplication and division have the same rules. So before I stack, I might divide all of these by 2 and see what I get. So instead of 14, 7, 6 is now 3, and 24 is 12. That divide trick will definitely come in handy when we're using the quadratic formula. If you make your numbers smaller, it probably will decrease your workload. All right, then you want to look here. I either need to get my A's to be the same or my B's to be the same. So I look at probably my B's because those are smaller numbers, And I think, what do 2 and 3 both go into? Or what would their common denominator be in a fraction? Well, they both go into 6. So then I think, well, how can I turn 2 into 6? Oh, I can multiply everybody by 3. And then this one, how can I turn 3 into 6? Oh, I can multiply everybody by 2. So if you do that, distribute that 3 and that 2, this is your new system. And I do realize this is what we had originally, so in this case, dividing by 2 didn't really save us any time. That's very rare. 99% of the time, it makes the problem easier. And then we'll go ahead and add them up. So I'll get 13a on one side, the b's cross out, right? We don't write 0b, and then we get 0. And you can't stop working because you got a 0. You just keep going with the flow. You would then divide by 13. 0 divided by 13 is still 0. So a is 0. And then if you put that 0 into either equation, it doesn't matter. Just to make time a little shorter, you're going to get 4 for b. So there's your solution. So in the last one, I'm just going to let you know, I'm going to use elimination. You're welcome to try it however you want. But go ahead and pause it, give it a shot, and see if you have the hang of it. And when you're ready, you can unpause the video and we can compare answers. All right, so if you got -3 for your x and 1 for your y, then I think you probably know what you're doing, so that's a good sign. If you want an idea of how to do it, I probably would have stacked them up, and then I would have made my x's cancel out. So I would have multiplied by -2, but to each their own. There's lots of ways to do this. So that's about it. And in Algebra 2, we actually will solve problems with x, y's, and z's in them, so we want you to be really good at this.